Hi everyone, welcome to Apex Hours. I'm Lawrence Newcomb. I'm going to be running through some summaries and considerations for a few different single sign-on identity flows. So just before I kick off, just wanted to say a massive thanks to Amit for having me. It's a pleasure to be part of Apex Hours. So a little bit about me. I work as a systems or technical architect for non-profit organisations. So it's been working with technical roles for about 15 years or so, the last 8 years, all exclusively for non-profits. And I've been working as an architect for about the last 5 years. I've been a CTA, Salesforce CTA since 2020. Also quite keen on open source development, and I built and maintain an app exchange product called Formula Share. It's completely free. It's helpful for dynamic record sharing, so really kind of complex record sharing scenarios on Salesforce. So allows you to do that without Apex code. Do also take a look at my website. So a lot of the resources that we'll be running through in this series of videos are available on my website. So do take a look there, and find me on Twitter too. So in terms of what we'll run through today, so there are 4 kind of main patterns to be aware of that can provide single sign-on for a Salesforce org. So the first 2 are SAML based, so service provider and identity provider initiated single sign-on. So we'll look at the steps involved in both of those 2 flows. There's a newer identity protocol that's also supported by Salesforce, OpenID Connect. This is based on OAuth technology. I will run through considerations and steps in the flow for that as well. And finally, delegated authentication. So this is typically used to integrate legacy single sign-on systems that don't support either of those other two mechanisms. In terms of people who should hopefully find this interesting, so Salesforce architects and devs, hopefully it's helpful for you guys. I think particularly anyone who's working towards the identity and access management designer exam, or preparing for the CTA board, knowing these flows along with a few others, quite important. We're going to be talking about some of the security considerations. So if you work with security and Salesforce, this will hopefully be useful for you too. And just generally everyone who loves identity and enjoys watching videos about it. So for each of the flows, we'll run through the main sequence of steps involved for each flow. So I'll actually walk through diagrams and explain what happens at each step. Just kind of focus on a few sort of particularly interesting aspects of each of the flows. So sometimes these are relevant to Salesforce, sometimes these are kind of quite general. And then also just summarising the particular points to consider if you're thinking of implementing one of these. So pros and cons of each of the flows. Unfortunately, we're not going to have time to go into real detail around practical points of implementing. So I'll mention a few things that are specific to Salesforce, but a lot of this is actually quite general information around these flows. I'm also not going to go into a great deal of depth on any of the technical or security points. Again, I'll mention a few things, but there's a lot of documentation out there and information that I won't have a chance to cover as part of these videos. So firstly, what's single sign-on all about? So in essence, single sign-on generally involves 3 different parties. So there's the user, so the person who actually wants to access some resources. So they'll often be using a browser. So the user is represented in the diagrams that I'll show by the browser that they're using. there'll be the application which holds the resources that the user wants to have access to. So this is basically the application that they want to use, that it will be authenticated. So in SAML language, that's known as a service provider. For OpenID Connect, it's a relying provider, but it's ultimately the application that will be serving resources once the authentication has been made. And there's the application that is doing the authenticating. So this could be a dedicated authentication application, something like Okta or Ping Federate. It can also be a lot of kind of big enterprise platforms, Salesforce, Google, Office 365, and so on. Can also be used as identity providers. And these identity providers or OpenID Connect providers. But this is essentially the application whose job it is to confirm the identity of the person trying to log in. And so all these flows kind of represent the interactions between these three entities. So there's lots of different analogies bouncing around on the web around single sign-on, and the one that I like the best, which to me kind of sums it up pretty well, is we can kind of think of the application which controls the identity, so the identity provider for SAML. So this is a little bit like the authority which would issue a license to somebody. So this is the body that is trusted to confirm the identity of a user. And in this scenario, this identity is being used by a user to negotiate with a service provider of alcoholic drinks to confirm to the service provider that this user is in fact old enough to buy booze. So just a few points around why we like single sign-on in general. So it provides a way of really consolidating the security around user login in one place. So if we have all our applications in an enterprise all being authenticated by a single identity provider or OpenID Connect provider, what that means is that we can ensure that there's a baseline level of security applied to user logins everywhere. So if we want to ensure there's multi-factor authentication, that certain login hours are applied, or IP restrictions, that can all be done in one central place, and we know that all applications that use that identity are already stepped up to the level of security. In some of these flows, it's possible to communicate information from the identity provider or OpenID Connect provider down to the applications which are being authenticated. So this can reduce the need to synchronize directory information between those applications, because the applications that are being authenticated get that information on the fly. So things like sort of job title, phone number, email address, that kind of thing can be received with each authentication action and updated in the consuming applications. It's also quite handy for staff turnover, because essentially the identity provider is the most important application to deactivate when somebody leaves. And if we do have all our applications authenticating through that one place, and that gives us some assurance that the user genuinely can't access any enterprise systems. And finally, everybody loves single sign-on. It's really convenient. There's just one hopefully strong password to remember. Once you're logged in to your identity provider, potentially it's just one login you need to make for the whole day if all the applications you're using reuse that session. So I'm going to be talking quite quickly, and I'm going to be using quite a lot of technical terms. So I'm not going to bore you with 3 or 4 slides with a list of what they all are, but I'll explain a few of them as we go along. But if you're not familiar with this stuff, do take a look on my website. There's a list of all the kind of the main jargon that we'll be running through in these videos. Service provider initiated single sign-on. So this is a SAML protocol, and it's a pattern which allows the service provider, so the application or the environment that the user wants access to request from the identity provider that they authenticate the user and confirm the identity. In terms of basic requirements, so all of the participating systems need to support the SAML protocol. So SAML 2.0 is the latest version of the specification. It's also recommended that there are all the up-to-date recommended security countermeasures to take into consideration, and there are mechanisms to support against those. So we'll look at a couple of those in a moment. We also require that the SAML sign-on URL and the certificate from the identity provider are configured in the service provider. So this is what the service provider requires to be able to call the identity provider. And then on the other side, the assertion consumer service URL, the ACS URL, and the identity ID from the service provider need to be configured within the identity provider. If we're using this pattern with Salesforce as the service provider, then my domain is also needed in Salesforce. So I'm just going to run through the main steps of this flow. So there are three main system actors involved. We've got the browser. So this is typically a browser-based implementation. There's nothing within the spec that says this is only suitable for browsers, but this is generally where you see it. The service provider, as I mentioned, this is the application that the user actually needs to access a resource from, and which will be authenticating to an identity provider. And the identity provider, so this is typically a system like Okta or Ping Federate. Salesforce can also act as an identity provider. Fundamentally, it's the system where the user has an account set up which can be authenticated, and that authentication used to provide confirmation of the identity to service providers. So the first step, the user will take some action within the browser that requests a resource from the service provider that is a protected resource, so they need to be authenticated to access it. And the service provider will check, is this user already logged in, and recognize that they're not. This is sort of the flow that's described in this diagram. There's also another use case for this, which is where a user accesses a login page within the service provider and then chooses to log in through the identity provider. So these first two steps are slightly different, but the rest of the flow is the same. So the service provider will then generate a SAML request. So this is then a set of attributes and a structure that the identity provider understands, which is a request for this user to be authenticated. The service provider will then redirect to the login URL from the identity provider that's configured in the service provider with that SAML request. So there's few attributes that are set. I've just called out here. One of the important ones for this flow is the relay state. So the relay state is the originally requested URL from the service provider. So the link that the user ultimately wants to end up on. So this bounces around the flow and ultimately comes back, so it can be served. The appropriate resource can be served to the user. The identity provider will or can verify the signature on the request. So there is an option for the service provider to sign the requests with a certificate or with a private key that corresponds to a certificate that's configured in the identity provider. So this would allow the IDP to be absolutely certain that the request has come from the service provider. The identity provider will process and pass the SAML request. If required, the identity provider will then
log in the user. So if they don't have an existing session at the identity provider, then the identity provider will use whatever mechanism it has to authenticate. So sort of serving a login page, or any other sort of multi-factor steps that are required. The identity provider then will build and construct the SAML response. So this includes a SAML assertion. On to a moment. The SAML response is then sent back to the service provider via the user's browser in an HTTP redirect. And so this goes to the assertion consumer service, which is configured in the identity provider that represents the URL that the responses need to go back to. And that signed SAML response will be included in this. So the signed SAML assertion will be included in the response. And within that assertion, we have amongst other attributes, the relay state is included. So the service provider will then verify the signature on the response, so to check that this response has come from the identity provider that it expects it to come from. This verification is a mandatory part of the spec. It'll validate the SAML response, so check are the parameters all valid? Is it well constructed? And does it come from the entity ID? Is the entity ID set as the issuer as the service provider would expect? The service provider will then issue a session, construct a session to be issued to the user. So as part of this step to authenticate the user, it would check any logic on the service provider side that would control whether or not the user should have access. So in the case of Salesforce, this would be things like checking is the account disabled, checking the login hours within the allowed range, that kind of thing. And the service provider will then serve the requested resource along with a session. So a few other bits and pieces to be aware of. So I mentioned the requests and the assertions are XML structures. So this protocol's been around since around 2003. So XML was a lot more common when this was first implemented. So this is sort of fairly suitable for a lot of browser-based use cases. But for mobile apps and even for mobile browsers, XML is quite a heavy protocol or a heavy structure. So it's perhaps not as ideal as some of the JOT-based options that are used in more modern single sign-on mechanisms. As I mentioned, this is on the whole used in a browser context. The request bindings from the bindings from the SAML request can be either set as URL parameters in an HTTP GET redirect or as a basic 64 encoded payload in an HTTP post. So that's depending on the implementation in the combination of the IDP and service provider, they would need to agree on how that's done. The assertion subject, so this is an attribute within the SAML assertion. So this is ultimately what contains the shared information that the IDP and service provider will correlate to know who the user is. So it could be a username, it could be something like an email address or some unique ID that's been agreed between those systems. You'll often see this referred to as a federation ID to denote that shared ID. There's a few things a few attributes within the assertion that make it specific to the context that it will be used in the service provider. So there's an issuer attribute. So this will be set to the entity ID of the identity provider. So this makes it very clear within the assertion who the assertion's been provided by. The audience attribute. So this is set to the entity ID of the service provider. And it's part of the specification that the service provider needs to check that the audience within the assertion is its own entity ID. So what this means is that an assertion can't be reused for other systems. It's only for the service provider that it's been constructed for. There's an in response to attribute that for particularly important for this service provider initiated single sign-on. So this will reference the SAML request that was made by the service provider, and will be used by the service provider to correlate with the request that it's sent, so that it can check that this is genuinely in response to an assertion request that it's made. This is also useful because it means these assertions can't be or shouldn't be possible to reuse or to use an assertion with an in response to in a context where a response hasn't been made. So these assertions can't be used to sort of simulate an identity provider initiated flow, for example. And then an issue instance. So this is the timestamp that the SAML request was issued at, and this will be referenced in the service provider to determine whether or not this assertion is within the allowed range. So most service providers will sort of allow a few seconds or a few minutes either side to account for timestamp variations, but generally, they'll expect the SAML response to come at, very soon after the request was made. There's also an assertion ID attribute, and this will be used for ensuring that there's no SAML responses are not reused. So in a good practice implementation, to protect against replay attacks, this will be important. There's a few extra security mechanisms that can be implemented. So request signing, I mentioned it as part of the flow, that can be applied by the service provider, and if we configure the service provider's certificate within the identity provider, then the identity provider can check and be sure that the request has been made by the authorized party. The assertion, as well as being signed, can also be encrypted for additional security. I mentioned so encryption, signing on both sides. There's a few certificates going around potentially. It's normally good practice, particularly in an implementation where we're working with systems with sensitive information, to use CA signed certificates to provide that extra level of assurance. There's also a session level attribute that the identity provider can set to indicate which what level of authentication was applied for this user. So if the service provider requires that the identity provider has a multi-factor authentication session, for example, that can be indicated here and checked at the service provider. There's also capacity within the spec to set custom attributes within the SAML assertion. So the identity provider can communicate other information that it has to the service provider. So this can be quite good for making the service provider aware of information that it doesn't manage itself, but might be useful. So things like job title, phone number, email address, that kind of thing can be inferred from the assertion that the identity provider provides. Single logout is supported through the specification. So what this means is when the user chooses to log out from the service provider, so they've kind of been logged in and they've spent some time in the system potentially, and then click a logout button within the service provider. The identity provider can offer a single logout URL, which is called from the service provider, and initiates logout both in the identity provider as well as the service provider. It's also quite helpful often to use to have some logic set up in response to an assertion being received at the service provider. to manage updates to user information or even creation of new users on the fly as assertions come from the identity provider. So in Salesforce, if Salesforce is acting as the service provider, this is done through a registration handler that can implement an interface that allows us to control the logic around the creating and updating of users. So you'll also see this referred to as just-in-time provisioning. So when's it a good idea to use this flow? Or a lot of these considerations actually apply to SAML in general. So SAML as a protocol, it's been around for quite a long time. It's really widespread in terms of usage. It's probably the most common single sign-on mechanism you'll see within enterprise applications. So it's often the only choice, and it's a good choice because it's well known, it's established, and it's generally secure when it's well implemented. I mentioned there's a few sort of best practices over and above the specification that are good to ensure are in place, particularly in sensitive implementations. But yeah, when it's done well, it's certainly adequate. The typical implementation of this is through browser protocols. So there's no back channel required as part of this. So depending on the technology capabilities of the systems involved, that can be a good thing. It also means it's quite easy to debug just using browser tools. On the other hand, just a few sort of potential considerations that might suggest that this isn't right for an implementation. So XML tokens involved are not ideal for mobile. They're quite heavyweights and yeah, not ideal, not as ideal as JOT tokens. It requires that the IDP understands some attributes from the service provider. So there's a requirement so when we're setting up a SAML configuration, we need to make some changes in the identity provider as well as the service provider. So normally this is fine in an enterprise environment because our teams would generally have control over both of those systems. But for a lot of external identity use cases, that can be quite a barrier to this being the right solution. And it's also adequate only for really sort of basic attributes being included as either the standard or custom attributes in the SAML assertion. So if we have rich data that we want to make available from the identity provider to the service provider, so things like photos, for example, that's not something that's really practical through this protocol.